This is how I made 2D Minecraft-ish with infinite world generation using a method I invented in Google Sheets with only formulas. I'll go over generally how each subsystem works, starting with how I store information: buttons, terrain generation, ore generation, infinite world generation, and the display. Look at the timestamps in the description if you want to skip anything. I won't be going over the inventory system or game logic because I don't feel like it. Each block has a corresponding character assigned to it in this page. I usually store data as lists of characters delimited by commas, and this is no exception, for the most part. Data is read from this list like a book, first left to right, then down. For example, a 2x2 with data AAFB, where A is grass, B is dirt, and F is stone, would look like 2 grass on top, a stone in the bottom left, and dirt in the bottom right. These buttons were designed by Tyler Robertson, whose website I'll link in the description. Also, this spreadsheet has iterative calculations on and max iterations set to 1, which basically allows formulas to reference themselves in a loop, and is required for game logic and buttons. The leftmost column is the input for the buttons, which references a checkbox. The rest is more complicated as it makes use of calculation order, so I'll explain that first. Google Sheets calculates formulas like you're reading a book, just like data reading order. It's worth noting this doesn't apply unless iterative calculations is turned on. If you're referencing something farther down in the calculation order that's changing, it will change one update after that formula does. Now that I've explained that, I can explain the buttons. Or not, because I'm lazy. First, I'll explain the noise algorithm I created called DRAN, Damped Randomly Accelerating Noise. To start, it generates the first level of noise. It takes 0, adds a random number, and multiplies by a constant, damping it and preventing it from getting out of control. It does this, in my case, 1,000 times. Then it creates the level 2 noise, the final level. Once again, it starts at 0, then adds the first value from the level 1 noise. Then it takes the new value and adds the second value from the level 1 noise. All the level 2 noise values are stored in a list delimited by commas. Then the values are transformed for the maximum and minimum values to meet my specifications, to ensure peaks and valleys. And now it's finally done. This generates noise that looks like this, and is done at the start of a world when the reset button is clicked, or when the player passes the already generated portion. The reason it's called DRAN is because level 1 noise is like the velocity, and level 2 noise is the position. So the velocity randomly changes, accelerates, and is damped. This is the tab that holds all the information about ore generation. I have a very similar system to Minecraft with triangular ore distribution. I specify the positions and likelihood of ore generating at the top, peak, and bottom of the triangles for each ore. Then, for every block, I determine the likelihood of every ore generating there using linear interpolation between points in the distribution triangle, and decide whether each ore should generate randomly based on its chance. I filter by most valuable in case multiple generate in the same spot, then choose the most valuable in the list. If nothing generates, it becomes dirt or stone. Although the terrain generates in chunks of 1,000, the world generates in chunks of 9. That's because that's the minimum value for only 2 chunks maximum to be visible at once. Every time the player would see an ungenerated chunk, I generate a new one. This process involves generating a dirt and stone version of the chunk with a section of the DRAN noise, then using the ore generation function to add ore to it. Then I append this chunk to a list of every chunk. Blocks in the chunk are delimited by commas, while chunks are delimited by semicolons. For performance, I only take the 1 or 2 chunks that are visible for display, then convert it from a comma and semicolon delimited list by chunk to a comma delimited list by visible screen, which the display requires to read the data. The screen is likely the simplest part. It takes the letter representing a block from the infinite world generation section and matches it to its image using this page.